Good morning, everyone, and welcome to another session of the RenderMan Art and Science Fair today. Today we've got a really great presentation, and it's going to be what we're calling a new integration with Blender. This is RenderMan for Blender, and in the past we had an integration with Blender, but that's with our previous architecture. This is a complete rewrite of an integration with the new version of Blender, and I'm going to turn it over to Ian Shea, the lead engineer on this project, and he's going to talk about all the new features, and he's going to give some great demos as well. Take it away, Ian.
Thanks, Wayne. Okay, to start. As Wayne mentioned, we've had a previous version of Blender working with RenderMan. That version was based on RenderMan 21, which was released in 2016, which was 4 years ago, which is hard to believe. The highest version that it was supported, it was Blender 2.79. It was RIP based, which meant that before rendering had to start, we had to write the translation of the scene to disk first before rendering began. It also had a limited IPR functionality, so you were limited to what you could change during IPR. So things like geometry could not be edited, you couldn't scale geometry, resolution couldn't be changed, and you couldn't add new displays. The last commit that we had to that code base was September 24th, 2018, which is almost 2 years ago. So I think it's time to refresh. So just to talk about what has happened since RenderMan 21. In RenderMan 22, we gave ourselves a sort of a mandate of being artist focused. And one of the things towards that is the notion of always on rendering. We didn't want the artist to have to stop and restart the render every time, there was a change to the scene. So some of the work that we did towards that goal was to rewrite the pipeline of how our DCC plugins talk to RenderMan. So we came up with this new scene graph API that we use to talk directly into RenderMan. So we no longer have to write to disk via RIB files. We also have a new ray tracing core, and we also have improved our light discovery algorithm. We've accelerated our particle rendering, and we've rewritten our curve primitive, so curves are basically the primitive that you use to render hair and fur. So the result of that work is that we're now up to 10 times faster for time to first pixel. Time to first pixel is basically the time that we measure between when you hit the render button and when the first pixel actually shows up in your frame buffer. We are now up to 2 times faster overall in rendering, and we also are up to 30%. Well, we use up to 30% less memory. We are currently at RenderMan 23.4, which was released about 2 weeks ago. So some of the new features that we've had since that initial release of RenderMan 22 is that we've now built in the NVIDIA Optics AI denoiser into our image tool frame buffer. We have new machine learning algorithms for light discovery. We have accelerated our OSL shading, which was a collaborative work with our friends at Intel. If you want to learn more about that, one of our lead engineers, Max Leoni, he did a podcast recently talking about that effort. Hopefully one of my coworkers will paste a link to that podcast in the chat. And we have new integrations with Mari, Houdini, and USD via our RenderMan Hydra delegate. So let's talk about this new Blender effort for RenderMan 24. So the things that are new in this effort is that we now support the minimum version that we now support is Blender 2.83 and Blender 2.9. The add-on is rewritten to take advantage of the new Scene Graph API, which I mentioned. So we no longer write to disk before rendering. Before rendering needs to start. Rib is we still do write rib files, but it's mostly for debugging and it's a viable way for batch rendering. So if you have RenderMan installed on your render nodes on your render farm, you can just send those rib files over to be rendered. We now render to the viewport as an option. So when you change the viewport shading to render, we can now send pixels back into Blender's viewport. We also have a new texture manager. I'll talk about that a little bit later. We have a new improved AOV manager. We have a light mixer panel, and we have pattern and illumination baking, and we have a lot more. And a lot more. So first look, okay, so let's play a video. So this is just a simple render. So we're just gonna start rendering the default Blender scene, which is the cube and point light. So we have new shortcuts in the object context menu here. So I'm just using it to switch the render engine over to RenderMan and then just starting an IPR render. So you can notice that we are now rendering into the viewport. We do translate some of the Blender lights. However, it's not sort of an accurate translation. Like we don't actually have a point light in RenderMan. So there's some limitations to that. So we sort of suggest users use the native RenderMan lights. So here you can see that I've brought in our teapot swatch model via an Alembic. And all of this is new. Like in RenderMan 21, we could not add new geometry as IPR was rendering. So here I'm just adding a sphere light, and then just gonna resize it and then change the exposure to lighten it up a little bit. We also have our preset browser, which is something that allows us to save materials and reshare them with other scenes. There's also light rigs and environment maps. RenderMan does come with pre-built materials. So here I'm just applying a textured aluminum material to the teapot. And then we've also have extra materials that are on the website that you can download. A lot of them were made by our technical artist Leif Peterson in our marketing group. I particularly like his car paint shaders. So here I'm just adding the Suzanne model, and then it's going to convert her to a subdiv. So you can do that quickly through our context menu here. And then I'm going to manually shade her with our Disney Principled shader, which is is our updated Disney Principled shader. And then I'm just going to add a bump map to Suzanne, and then use a Worley to drive the bump. One of the things that we've added is soloing. So you can solo any of the pattern nodes in your network here. So here I'm just soloing the Worley texture. So that allows you to sort of focus on one of the nodes in your network without having to, or independently of all the other nodes in the shader graph. And then I think finally I'm going to add a light filter to the sphere light. Light filters are basically plugins that you attach on top of lights that they allow you to sort of manipulate the shape of the light. We have blockers, gobos, and then here I'm just going to use a ramp light filter, which creates sort of a ramp texture of of the light color. So here I'm just adding a couple of color knots to the ramp. So you can see that it sort of creates this ramp texture. And then you can sort of reshape it, change the distance of the ramp. And I think that's it for that video.
So what machine did you record this on, Ian? Was this on the AMD Threadripper?
Yeah, that was on the AMD Threadripper.
Yeah, so this is on the latest AMD Threadripper for folks asking in the audience.
Other things that are new, we have our new visualizers for our lights in the viewport. This is the same, we're using the same GL code that we share with our other DCC applications. So the top row there is our disk, our portal, and our distant light. And then the bottom row is our rect light, cylinder light, sphere light, and the environment daylight. Other things that are new is we now support the new OpenVDB node that was added in Blender 2.83. We also have new workflows for baking, so you can now bake both 2D and 3D textures. So the left there is a 2D texture, and the right is the same model, but it's a 3D point cloud. Something that we added in RenderMan 23.3 is the ability to bake illumination as well. And then we have rudimentary support for Blender's grease pencil. It's still a work in progress. Most of the strokes and fills will be translated, but we do have issues when the fills are overlapping each other. So if you notice on Suzanne's, the eyes, it kind of sort of, the pupil and the eyes and the skin sort of blend in with each other. That's something that we're trying to work on, but some of the ideas that we have would require sort of changes to the core renderer. Some new UI. So I mentioned that we have a new texture manager. So RenderMan still requires textures to be converted for cache and efficiency purposes. That conversion should be mostly transparent to the user, so you shouldn't need to worry about that too much. However, there are times that you may want to sort of change the settings for a certain texture, such as the wrapping mode. And you can do that in the texture manager. Some other things, as I mentioned, is the AOV manager. So you can now add new displays, and you can change the file format that the AOV gets written out. So you can write TIFF, OpenEXR, or you can do like a deep EXR for if you want to do compositing. And then we have our light mixer panel, which is basically just a sort of a convenient way to edit a group of lights all in one place. We also have some extra viewport controls as you render in the viewport. So I'm going to play another video. So this video is all about the light mixer. So this is our photo studio scene that you might have seen in our other sessions and other rendering in other DCC. So here's it's rendering in Blender. So you can open the light mixer panel from either the scene properties or from the context menu. So to begin, you create a group, and then you add lights to that group. So from the drop-down menu, it shows all the lights in the scene. You can, if you have a lot of lights, you could also do a filter search. So here I'm just gonna try and search for the left and the right panel light. And then as you click through each light in the panel, it'll also highlight or select the light in the scene as well. So you can, you're doubly sure that you've actually added the correct light. So some of the things that you can edit in the panel is some of the common parameters like light color, intensity, and exposure. And then you can also do if you don't want to deal in light color, you can also do the light temperature as well. The right two icons are for soloing and muting. So here I'm in the video, I'm actually soloing the overhead light. So basically when you solo the light, it'll turn off all the lights in the scene. And so you can just concentrate on that particular light that you want to edit. And then the rightmost icon is muting. So when you select the light and then click on that icon, it'll turn off just that light. And it's a sort of a convenient way to see how much of that light is actually contributing, and sort of, you can see like different lighting scenarios. Maybe you don't really need that light. So here I'm just going to solo the right light as well, and then just going to change the color. Okay, so I'm going to show. So the next video is all about the viewport controls. So when you start rendering into the viewport, we add some extra operators. So the first thing I'm going to show you is our integrators menu. Integrators in RenderMan are basically plugins to RenderMan that change the light transport algorithm. So here I'm going to choose the Pixar occlusion integrator, so that changes to rendering an occlusion. It's a good way to sort of show where all the shadows are actually falling in the scene. And then I'm going to show the visualizer, which is, I'll just do like a simple wireframe render. And it's good for if you just want to check the animation independently of the shading. The next thing is the interactive refinement value. That controls how much of the pixels get updated for each edit. A higher value will leave a lot more pixels behind for updating. It's a good way to sort of boost the interactivity as you edit your scene, but too high of a value will actually cause sort of a ghosting effect as you render. But so you really want to kind of tune it to based on what you're rendering and what works for you. The next is the resolution scale. So we have an option to scale down the resolution, and this is useful if you have a slower machine, but you don't necessarily want to resize your viewport. So you can do like half the resolution or a quarter of the resolution. So the next thing is the channel selector. So if you are rendering, if you have AOVs rendering in the scene, this is just a quick way to inspect any of those AOVs that you're rendering. So here I'm just looking at the direct diffuse, and then I'm just going to select the indirect specular, which is sort of the reflections in your scene. And then just go back to the beauty. The next thing is the crop window. Crop window, if you want to just sort of focus on a specific portion of the scene, you can draw the crop window, and then only the pixels within that window will be updated. So here I'm just going to focus on the neon sign there, and then I'm just going to change the color of the table, and then I'm just going to change the color of the neon sign. You can move the crop window around to any portion of the scene, or you can resize it as well. So you just drag it from the corner of the window, and then once you're happy with it, you just re-edit the crop window and just click the X to get rid of the crop window, and those just render the whole frame. And then finally, we have a snapshot button. This basically saves a snapshot of the viewport into the Blender image editor. And this is useful if you're sort of like showing clients sort of like different lighting scenarios and different color scenarios. So it's just a quick way to quickly save an image to show. Okay. Go. And then if you've attended some of our other sessions, you may have heard of Llama. So in RenderMan 24, we are including the new Llama materials that were developed by our friends at Industrial Light and Magic. Llama stands for layered material, and it's their new layered material system that they've used on some recent productions, such as The Irishman. So I'm just going to demo shading our this year's walking teapot with Llama in Blender. Okay, so here I've brought in the walking teapot as an Olympic, and I'm just going to start rendering. For Llama, you basically start with a Llama surface BXDF as your basis. The Llama surface has options for shading two sides, the front and the back. But since we're not actually going to look inside the teapot, we'll just set it to 1. And then we'll use a Llama stack, which allows you to stack 2 different lobes. So for the base, we'll use a Llama diffuse, which will act as our paint layer. And then for the top, we're going to use another Llama stack because we have 2 different roughness maps, and we're going to use that for our 2 specular lobes. So for the first one, we're just going to use a Llama dielectric, and we'll just use Pixar, our Pixar texture to bring in our first roughness map. And then for the top one, we'll also use another Llama dielectric, and then bring in the second roughness map with our Pixar texture. What is Llama? Llama is our layered material shader that was built by ILM. And then we also have a height field map. So we're going to bring that in as our bump map. Here I'm just using our new Pixar bump mixer, which is a new node that we have that helps to mix different bump signals together. And then finally, I'm just going to go back to our diffuse layer, and we're just going to bring in our pegacorn texture via Pixar texture. We also wire that in through our Pixar remap nodes, so that we can remap the values of the texture a bit. So here we need to, because it's upside down, we use the invert T to invert the map. And also because it's a color map, we want to make sure we linearize the color map. So we do that we click the linearize option in Pixar texture. And here I'm just going to bring down the color a little bit just to match the original model. So this is what it looks like rendered out of Blender. Walking. Let's play that again. It's pretty cool. Like, I didn't actually have to denoise that. It came out pretty great. So just to close out, I was told to remind everybody that we have teapots this year, but it's a sort of a VR teapot, and we are running a contest. So if you could put the teapot in various poses and put it on Instagram, the one with the most likes will get prizes. So the prize is 3 commercial licenses of RenderMan, a Katana license and a Mari license from the Foundry, and 1 Houdini FX license from our friends at Side Effects. So I think that's all I have for today. Hopefully that shows some of the, it'll get you excited about upcoming RenderMan for Blender. I also wanted to thank the whole RenderMan team for sort of believing in me and believing in this project and being very patient with me when I had to ask a lot of stupid questions. So thank you.
All right, that was great, Ian. And you know, stupid questions are the best questions because that's how you learn. So we're going to move into a question and answer phase now. Lots of folks have lots of questions. This is a really, really impressive new project. And if you don't mind, I'm going to go ahead and close your slides so we're a little bit bigger on screen. Hi, Ian. And so a lot of folks were asking what hardware you were using to record that demo on. And I looked it up. It's the latest, it's just a standard Threadripper workstation. It's not the same as the lighting workstations at Pixar. Those are currently Intel machines, but it's a 64-core Threadripper, and it was running at 2.9 gigahertz with 256 gigabytes of RAM. It also contained the RTX 2080 Super, but keep in mind that the version of RenderMan that Ian was showing was not utilizing that GPU for rendering the pixels. The version of RenderMan that he was demonstrating was using what we call the RIS architecture, and that is a CPU architecture. And RenderMan is actually really efficient on high-core CPUs as well. Now we're also working on an XPU project that utilizes the GPU as well as the CPU at the same time to render pixels. However, we didn't demo that today in Blender, but I'll ask you, Ian, do we expect XPU support to be coming in when RenderMan 24 is released for Blender?
Yeah, so the great thing about the Scene Graph API that I mentioned, that it basically sits on top of RenderMan. So whatever the backend is, it'll just accept whatever we send it to. So it's just a sort of a flip of an option to whether or not you want to render with RIS or XPU.
Yeah, that's great. And some other folks have asked if we've presented this new technology for non-photorealistic rendering in some of our earlier sessions, and there'll be another session as well about it in detail. Will we plan to present non-photorealistic rendering in addition to Grease Pencil for
Blender? So that should all be supported. It's just excellent. It's just plugins.
Yep. So if it's supported in RenderMan, it's effectively going to be supported in RenderMan for Blender. Grady asks, is Pixar using Blender internally for anything? Maybe I'll answer that one. Someone also answered online, but currently we're not officially using Blender at Pixar for production work. Obviously, a lot of artists are fans of Blender, including those of us on the RenderMan team. And they use it for personal projects or, little art projects. But currently it's not in use at Pixar officially. How will this be updated? Will the Blender Foundation be involved with it, or is it just work on Pixar's end? I'll hand that off to you, Ian.
Yeah, so I think this is sort of independent of the Blender Foundation. We will, regarding our release cadence, we will try to match the release with RenderMan as it's released. The code is all open source, so the code will be available on GitHub for anybody to look at. And if you want to make modifications, we will, and do pull requests, we will try and integrate that in as well.
So we're following the same model with the previous version of RenderMan for Blender. Yeah. So an open source license, we encourage the community to contribute. It's one of the things that makes Blender so powerful. The reason they can put out such amazing pieces of software with so many great new features is because the community of developers and artists is really engaged, and it's really powerful to see how well they do that. Okay, so
I think I saw a question on fur rendering. I'm not
yeah,
sure
yeah,
what-
I was going to ask. You didn't show a demo of fur
yeah,
and particles, but
yeah, all that should be working. Like fur, you do translate it as RI curves, so it should match pretty closely to what you see in the viewport. And we do include two different shading shaders. We have the Martian hair shader and our new Pixar Chang shader as well.
yeah, so you can do human hair or animal fur. And I have seen Ian growing hair out of Suzanne's head, which is kind of fun to see. We just didn't have enough time to put that in the demos. Let's see. A lot of folks are asking about the cost of RenderMan and is it free? Can you talk a little bit about the non-commercial and commercial versions of RenderMan?
Yeah, so we do have a non-commercial licensed version of RenderMan. It's, even though we call it non-commercial, it's the same, it's the same bits really. It's the same binary. The only limitations is basically where sort of the work that you can do. You can't make money off of it.
Yeah. We don't want you using the non-commercial version of RenderMan to render your, animated movies or your animated shorts or, your commercials for broadcast. And the license terms are on the website.
But we do encourage people to use it for their demo reels and stuff like that.
And learning and just becoming enthusiastic about RenderMan. That's the best thing about the non-commercial version, is it gives you a chance to kick the tires. If you're an expert, it gives you a chance to do, to really see what RenderMan can do. If you're a beginner, it really lets you learn how RenderMan works. And it's really great for students who are just, getting off the ground, especially combined with an open source project like Blender. Let's see. They say this can be a tricky question, and I like tricky questions. Where did that one go? He was asking if, we previously supported it up to RenderMan 2.79, and then it took us quite some time to re-architect it, for the new fully interactive architecture of RIS. Do we plan to support Blender from now on? I mean, indefinitely. I guess indefinitely is a strong word, but do we plan to continue?
I hope so. I think I really enjoyed this project. To me, it was like a love labor. Honestly, when I started working on this, I was doing this during after hours of work. I was doing it during the night, and my initial goal was just to basically update it so that it would work with the new interactive APIs. And I was hoping just the community would just take over. But, Oliver, I think, saw the potential in it and wanted to
make it an official product.
Official product.
So we adopted it, and we do plan to continue to support it as an official product. Certainly, if Blender takes, if there are significant changes to Blender, which there have been. Again, this is a dynamic project, but we plan to, engage with the developers at Blender, and we know a lot of those guys quite well, and they do great work. So I don't see any problems in continuing to support it. And we kind of did continue to support it. It just took us a while to adopt this significant new architecture to give us all these great new features. Ricardo asks, sorry for being too geeky here, but curiosity can't be stopped. Is it a specialized build of Blender delivering this integration, or is it a fully Python-based integration with wrappers into the Riley interface? And how about your C++ display driver? So maybe you can go into some of the developer details.
So this is all Python-based. Everything in the add-on itself is all Python-based. So we're just using all the Python APIs that Blender provides. The only C++ part of it is the display driver. We plan to also open source that as well. So if you want to take a look at the code and modify it as well.
Yeah. So you'll see how that display driver gives us this nice integration to display our pixels in the Houdini display window in the Houdini display render, which is quite nice. Jean Michel asks, what is the main difference between cycles and RenderMan? That's a really good question.
It's kind of hard to answer, sort of, but they are both path tracers. If you're asking more of like which one is the better renderer, it's kind of hard to answer that question. But I think the answer to that is that we sort of stand behind our renderer. It's been used in productions. It's what we use at Pixar to render our films. So we are confident about our renderer.
Yeah, I think that's great answer, Ian. RenderMan is a production grade renderer. It's used by a lot of large production companies to produce many of the special effects in movies you see every day. And with that in mind, it's focused for large data sets, and it's focused to be stable, and it's focused on ease of use when it comes to both look development and lighting. So that's great. And then, on a follow-on question from Brian Savory is, are the cycles materials going to be translated, or is this your own custom RenderMan material node graph?
So we do have code to translate the cycle shaders. It's not going to be an exact one-to-one match, and there is some work to be done, mostly because there are certain OSL features that rendering or cycles use that we don't support in RenderMan, such as closures. So I think with our commitment to Material X in the future, I think that that line's going to blur a bit.
Yeah.
So
I think so too. And a great follow-on question to that is, how about USD? Like, what are the USD capabilities? It's more about Blender, I guess, but RenderMan for Blender is obviously will play into the USD pipeline and future.
Yeah, I think we always pay close attention when it comes to USD. Yeah. If Blender all of a sudden says they're going to support USD and Hydra, I think we can easily plug into that architecture.
Yes. We're fortunate that we have members of the USD team co-located with us here in Seattle, and we work closely with them in Emeryville, California as well. So yeah, we're pretty involved with the USD efforts. Let's see. Someone asks about a skin shader. Can you tell me a little bit about subsurface shading capabilities with RenderMan for Blender?
Yeah, so the subsurface scattering is a part of the shaders. There's different modes that Pixar Surface and the Llama shaders include. So we have a path trace version of the subsurface scattering, and we also have the Burley model as well. So it really depends on which model you like. You can play around with it, and you can look in the docs for images of the different types of subsurface scattering algorithms.
Yeah. Let's see. Giuliano asks, will RenderMan for Blender have real caustics, or how would you go about, rendering caustics in your scenes?
We do support caustics. It's just another mode with the integrators that we include. I don't know if that answers that question, but yeah, I think the quick answer is yes, we do support caustics.
Yeah. So you can generate them a couple of different ways.
And I want to point out that Leif just put a link to the tutorial which talks about the manifold block.
Yeah, there's a manifold next event estimation, which is a really great capability of our unified integrator that really cleans up and makes for efficient caustic rendering, physically based caustic rendering. So, Grady O'Neill asks a great question. He says, what motivated Pixar to develop this bridge for Blender? Is it market share?
I think, for me, just being selfish. It was just for me to way to learn the RenderMan APIs. And you know, I think we always get this question is like, how do I use RenderMan? And we want to sort of, you know, spread it across as many DCCs as possible. And I think Blender, it sort of brings about, it's an easy way to integrate it because it's all Python based. There's no, you know, you don't have to compile it.
Yeah.
It's very quick to integrate.
Yeah, it was nice to build RenderMan for Blender on multiple fronts. One, it broadens. It potentially could broaden market share. That was actually not our driving goal. More of the driving goal is to get RenderMan more into the hands of more users who are interested in using it. And it also provided us an opportunity to develop our Python interfaces for RenderMan. So it gave us this great testing ground to ensure that we could develop Python interfaces that let us drive RenderMan in an interactive way. And there's really nothing better than Blender to make you up your Python game. And it's a great development environment. I don't know how well you enjoyed working with Python, but
I think it's a great API, and I think the developers are great too. Like when I filed the bug reporting about Grease Pencil, they basically fixed my issue like overnight.
Yeah. Again, it's pretty impressive that the community with Blender is so responsive with their development. So, Dimitri asks, when will this version of RenderMan for Blender be available, and what are your plans for releasing it?
So we are going to, like I said, we're going to try to match the release schedule of RenderMan 24. So we are going to beta in December, with a targeted release next year in Q1.
Yep. And then I'm getting down into some of the other questions here. Some folks ask how you define commercial. The license terms for non-commercial RenderMan are detailed by the lawyers on our website. So if you're interested in the actual details, it'd be good to look on the website. And then let's see. Someone asked, this is a great question. Will RenderMan for Blender have light linking capability? So will you be able to actually, say this light shines on this object?
Yeah, that was one of the points that I had mentioned in the what's new slide, which is light linking. We have a light linking editor. It's very similar to the light mixer panel. You basically add a light and then you sort of pick the objects that you want to link against that light.
Yeah, it's a pretty common thing to do, and the lighting technical directors at Pixar achieve some really great things with light linking capabilities. And not only can you link lights, you can also link light filters as well. Is that capability there as well?
Yeah, it's all there. Yeah.
Oh, that's fantastic. That'll be really powerful. And then Doug asks if there's support for rendering fire and smoke, or is OpenVDB use constrained in any way?
We do have support for the fluids in Blender. Unfortunately, it's not the fastest way to render those, mostly because I think they have a really odd way of writing their OpenVDB files, which sort of doesn't
match with the industry.
Expect, unfortunately. So, but we do try and render on an uncached version of the fluids.
All right. Well, we're approaching the end of our time here. I'm just going to pull out one more question. Abel writes, thanks for this. This is really great work. And they ask, does the new RenderMan for Blender support deep data EXR output?
Yeah. So I sort of mentioned that in the slide about the AOVs. So you just need if you want to render a deep EXR, you just change the file format, or basically the sprite driver to DPXR.
Yeah, you can just switch from writing out flat EXRs to deep EXRs by just selecting deep EXR, and then all of your data comes out you can then do all kinds of fun, deep compositing tricks. So. All right. Well, that session was great, Ian. I hope everyone out there is excited about RenderMan for Blender. We certainly are. And hopefully you'll be able to download it once it becomes available. And
yeah, and I also wanted to give a shout out to Jonathan Dent, who has been helping me in the last 2 years on this project. So big thanks to him for helping me out.
Awesome. All right. Thank you, guys. And if you want to attend some of the other sessions, make sure you can register with the pop-up here. And see you later.